Hey, what's up, guys? Welcome back to the Ramsey Custom Shop. And you see we're on Facebook here, and this is a video that I shot a couple of weeks ago, and unfortunately I've lost some of the footage. I had two cameras set up, and I reformatted the memory card on one of the cameras and lost all the cutting footage. So you'll get the gist of what I was working on here. The one thing I wanted to mention real quick is about the Trucutcnc table. A lot of people ask me about it. A lot of viewers on this channel have actually purchased the table and are now part of the TrueCut family. And when you join the family, you get to become a member of the TrueCut owner share. And before you go requesting to get on this page, you have to be an owner to get at it. But I wanted to just show you again. I've shown this a little bit in the past. You can see there's 190 members. Now obviously they've sold a lot more tables than that. Or just slowly over time, the old owners are figuring out that this site exists and are joining. But the one thing I wanted to mention real quick is right now through the end of July, they still have free shipping on any table that you purchase. And I, for one, can tell you that when I bought both of my tables, I didn't get free shipping. So for the last, I don't know, I think a year or so, they have been offering free shipping. So if you've been thinking about getting one of these tables and you've kind of been kicking the can down the road on it, you need to jump in, because this is about a $1,000 to $1,500 savings on a table if you, as opposed to paying your own shipping. And if you buy a table from any other company out there, you're pretty much going to be paying your own shipping. So I wanted to just show you this site real quick. You can see people are posting in here every day, every couple of days. People asking, questions. Anyone got a plate roller? People sharing things. This is Jimbo Dalton's rooster that he did, and not only did he cut that. Let me scroll down a little bit. He actually, after he cut it, he came and uploaded his CAD file. So now you can go over here to the files link, and you can see it there, and I can go download it. There's all these CAD files people are sharing. It's just a great membership to be a part of, and a huge advantage of buying a TrueCut. I know a lot of people, companies out there make good plasma tables, and I'm not trying to say TrueCut is the best or whatever. They make good tables. I'm happy with them, but I don't think you can beat this community that of collaboration and support. Because I mean, the mechanical parts of the table and the software parts of the table, I mean, that's one thing to work out in TrueCut. They'll get you going on that. But the whole real challenge is the actual operation of the table and the CAD files and the creativity, and how do you actually do something with it to make money and to make it work for you. So the one post, let me scroll down here a little bit and see if I can find it real quick, is what this video is about. I came on here, and this was a couple of weeks ago. It was a day in the shop, and I needed to rip some stainless tubing down the middle, and I was looking for some advice on it, if anybody had done it before, because I knew it was going to be a challenge. And as you see here, the post I made and the responses, and of course, often the response you get is from Richard Carlisle, also known as Ross Carlisle, who is the owner engineering, the owner, designer, engineer of the company, along with his wife Cindy. You see her; she posts a lot in here as well. So you can see this thread here where I started, and as I was working in the shop that day that this video was shot, people were leaving comments, and I was taking some of their suggestions, and of course my own ideas as well. But it just goes to show you, if you're a single, self-employed single guy working in your shop, it's often helpful to have somebody else to bounce things off of, to ask questions. So anyway, guys, let me get you onto the video. You can see what I was working on, and don't forget about the free shipping. If you've been kicking the can down the road, you need to pull the trigger. Give them a call. Thanks, guys. See you. Hey, what's up, guys? Welcome back to the Ramsey Custom Shop. My name is Gary, and it's Monday morning. We're here in the shop. We've got this job, and my question to you is, do you trust your equipment? Do you trust your plasma table, if that's what you're using? Because that's what I'm using today. And I think it really comes down to, like, how much you trust your table is related to how much, what you're willing to try to test on it. And I cut a lot of regular sheet metal in here, 16 gauge cold rolled. So it's $60 a sheet, whatever. I mean, if you make a mistake or the table crashes or whatever, you're not really risking a lot. But I know a lot of other guys, and including even myself at times, cutting heavy plate on there that's $800 or $900 a sheet. And even one TruCut owner told me that he had a job that he was cutting 3/8 3/16 stainless sheet, and it was $1,600 per sheet. So you need to really trust your equipment and trust your machine if you're going to do that. So I'm not doing that today, but what I am doing is, let me show you real quick what I've got here. This is some 1-inch stainless square tubing that's 120 wall thickness, and I can't remember how much a stick of it is, but it's not cheap, I can tell you that. And I have a need to rip it down the middle, split it basically, and I've done that on the vertical bandsaw over there, and it worked well on a little small section, but I got to do a bunch of it. I have 3 sticks of it there, and I don't want to push all that through the vertical bandsaw. So we're going to cut it on the plasma table, and let me take you over and show you what we got to do here and what we're working on. All right, let me show you what I've gotten here to get it to this point. So I already had this on the table from a couple of weeks ago, and I just left it on here because I knew I was going to be doing this. And it's a piece of 3/4 inch flat bar, 3/4 by 12, really heavy. It's not going to move around. And this stainless, if you've ever done any plasma cutting of stainless, man, it really takes the heat input and wants to move around. Even cutting these little flat bars, I had to put a lot of weight on it to keep them from moving. So we're trusting that this flat bar is square. We're trusting that it's straight, and we've got it butted up against the edge of our table using the squareness of the table and the gantry running on the table to make an assumption that we're going to get a straight square cut down through there. Now, do I have this exactly butted up here, down there? Are these big flat bars really square and true? Probably not. We're probably not going to be super square here, but this is something we can check, when we get done. And for this application, I don't need it to be perfectly straight. And if we need to tweak it on the grinder a little bit, I'm gonna have to grind the edges of it anyway because it's got to be welded. We're gonna have a plasma cut edge. I've also raised the water level of the table all the way up, touching the bottom of the tube, because it's gonna get to help with the warpage. Because again, stainless, and being this part being up above the table and not submerged in the water, or at least the full bottom of it touching the water, it's gonna want to move more. So that's what we got set up there. And what I did here was I just opened one of the parts that I had previously cut, and so 10 gauge stainless. These are some of our parameters. You see we need a THC set voltage of 83. I know my table runs a little bit lower than that, so I've got it set at 80 to get the correct height. We're gonna run the feed rate at 70 inches a minute. The book says 75, so a little bit under. And then there's our pierce height, cut height, and pierce delay. So to actually make this straight line cut, I'm gonna go, not even into any CAD or anything, I'm gonna go up here to Shape Wizard, and I'm gonna pick out the line, and we're gonna make a 36-inch cut to start with. So, man, I'm having some, sorry about that. I had a focus issue there with my camera. So we're gonna cut 36 inches down to this first clamp. And one of the things that we're gonna do is we're not gonna completely sever this. We're gonna pierce, maybe 1/4 of an inch or 1/8 of an inch in from the end. And we're gonna cut 36 inches down here, and I'll take this clamp and move it over that way. And we'll leave about a 1/4 inch gap, and then we'll cut it all the way down to almost to the end. And then I'll take a grinder at the end and nip the little tabs to separate it. And that'll keep the wall, keep the cut piece from wanting to collapse in and cause further distortion, and maybe the whole tube may want to bend if we don't leave that intact until we get it to the end. So let me put these links in here. So we're just going to specify 36 inches there. Here, I'll just do it real quick. I know we got some glare here, and normally I would be doing a screen capture, but since I'm actually doing this on the actual computer, I don't have screen capture software on here, so we're going to say run part, and if we go over here to program run, you can see our 36-inch line. It's actually going. All right, we just did a little quick test cut there to double check our measurements and make sure we're accurate. So just kind of doing a quick, you know, again, this is not scientific. Looks like I want to move that over just a little bit closer to that edge, but we'll tweak it, and then we're going to cut 36 inches or 30 inches or so down to that clamp, and then cut the rest down to that one, leave those tabs in, and go from there. All right, so I don't know if you could see that in the video or not, but the torch was rising up, and if you notice right here, I don't know if this will pick up either, but the amount that the tube is sticking up there, it's actually sticking up quite a bit more, you know, maybe 1/8 of an inch higher. So this, you know, I really need to be running torch height control, and I actually turned it off for this. You can see it's off there. So I'm going to turn it on, and you know, again, we're talking about warping. Look at that, how that tube is really warped up there. So we're going to let it cool a little bit, and then I didn't have a clamp down on this end either. And we might just do some 12-inch sections just to minimize the heat. You know, cut it, stop, and then cut it some more. So we'll keep experimenting and show you what we end up with. All right, so I don't know if you saw that, but they warped really bad. So I abandoned that for a little while, and I came over here and set this station up, and got my grinder out, and I went through and cut a bunch of them, just split them manually with the grinder with a cutoff wheel on it. I've already been through several cutoff discs, crap everywhere, and I gotta be honest with you, I'm hating it, and it's going really slow, and it's taking about one grinding disc to get through each one of those sections. So I did one, and just did a little fit up and weld on it here, and you see my weld's kind of crooked. Well, that's how I cut it, you know. So then when you go try to weld over it, you weld crooked. So some of them are crooked and some of them are pretty nice. You can kind of see that one there. It gets really big. Now I need to do a little fitting right here well, actually that one's sitting on the wrong side. It goes on this side. But on this one you can see it's not too bad, but I'm really not liking that grinder at all. But I was wearing a shield and respirator, and you know, normally I don't wear a respirator just for a quick little grind on this or that, but when I'm gonna sit there and grind for 4 or 5 hours at a time, yeah, I put the respirator on, do it over there by the door so I can keep it out of the rest of the shop. So anyway, I've decided I got a bunch more of these to cut, and I'm not going to sit there with a grinder, run through a bunch of grinding wheels. So what I did was I took the 45 amp tip out and put a 65 amp tip in, and the book spec on, we cut that first one at 75 inches a minute, or 70. The book said 75. The book on the 65 amp tip with the same thickness is 240 inches a minute. So even though it's 20 amps more, it's running at more than double the speed. So, and then the other thing I did was I took a piece of aluminum solid stock there and clamped it beside it. So now we have a heat sink. It's actually kind of sandwiched between two heat sinks. I also raised the water level in the table up. Yeah, I don't know if you can see that or not, but it's about 1/4 of an inch up on the tube now. So we're gonna give it another try and see if we can get a straight cut on it and keep it from warping. So stay tuned. All right, so here's the tube I just cut, and I just went ahead and quickly hit it with a grinder on the edges so we could weld them. And of course those are the two test pierces, and I'll grind that out a little bit more. Leave a little bit of a gap, but we can fill it, no problem. And I've got to tweak these tubes a little bit, and I've got to tweak that adjustment. This tube here is sitting higher than that one. And I measured this leg here, and this leg is a little bit too long, but we'll tweak our torch and get the rest of them cut. So in recapping on this whole scenario here, I mean, I think one of the cool things is that, you know, you can use your plasma table for things that you wouldn't maybe think to use it for. A whole bunch of straight cuts in stainless steel is not a fun project, and that torch doesn't care. It doesn't take any more consumable life to cut mild steel versus stainless, but it takes a whole lot more grinding disc and bandsaw blades, drill bits to mechanically cut it, machine it. So the changes I made, the chill block, the 1-inch aluminum chill block, that made a difference, raising the water in the table. But I think the main thing was putting the 65 amp tip in there that we could run at 220 inches a minute. So we're not dwelling on it and putting a lot of heat into it. It's just ripping down through it and it's done cutting by the time it, you know, the heat saturates into it. I'm gonna wrap up here by showing you, you know, if you work alone and you're thinking about adding a plasma table to your shop, check out TrueCut, because not only do they build a cool table, it's really more about buying into a family. And if you're self-employed and you work by yourself, take a look at the post. There's a dedicated private Facebook group for TrueCut owners, and we collaborate on there every day. People post what they're doing, they ask questions, and when I started on working on this, I put a post on there. I'm just gonna walk you through that real quick and show you a little about it, and show you why, you know, I think the TrueCut, you know, servos, steppers, you know, whatever, table configuration, everybody's got, you know, there's other good companies out there. A lot of companies make good tables, but I would really challenge you and question you to find another company that has the level of support that TrueCut does, and not only just, you know, kind of stands behind their tables, and if something goes wrong with it, they'll help you out. But there's a lot more to owning a table than just the maintenance of it. You know, there's the actual application of it and how to use it. So take a look at this post real quick on Facebook, and then we'll wrap up the video, and that'll be it.